Okay, good day class. So for today's lesson, we will discuss endogenous processes in our module 2 second quarter. So at the end of this module, you will be able to describe how magma is formed by the process of magmatism, describe different types of metamorphism, describes the changes of mineral components and textures of rocks due to changes in pressure and temperature. Describe how rocks behave under different types of stress, such as compression, pulling apart, shearing, and in addition to this, we have also the confining stress. Endogenous processes of Earth. The endogenous processes are caused by forces from within or in the interior of Earth. The driving force is the thermal energy of the mantle and the crust. Most of the thermal energy originates from the decay and disintegration of radioactive elements in Earth's core. So this explains that the Earth is shaped by many geological processes. Processes caused by forces from within the Earth are endogenous processes, meaning these changes happen inside the Earth's interior. Indu is a prefix meaning in or inside the Earth. In geology, endogenous refers to all the processes that are produced in the interior of Earth and other planets. The heat transfer towards its surface drives endogenous processes. That is referring to our thermal energy. Earth is close to a steady temperature state. Means that many of the rocks in Earth's crust and interior undergo this process of radioactive decay. This process produces subatomic particles that seep away and later collide with surrounding materials inside the Earth. Their energy of motion is converted to heat. That is why there is a different kind of endogenous processes because of this radioactive decay. Next, the endogenous processes of Earth is responsible for earthquakes, movement of plates leading to development of continents, mountain buildings, volcanic activities, and other movements related to Earth's crust. Some of the endogenous processes that played a role in the evolution of landforms on Earth are. Okay, so in addition, an earthquake is an endogenous process as well. An earthquake causes quakes, destructions of buildings, landslide, soil liquefaction, subsidence, and changes in relief. Endogenous processes cannot be separated from exogenous processes that we have already discussed a while ago. Exogenous and endogenous factors are interconnected and together affect the structure of the planet Earth. Okay, so we have the first type of endogenous processes, the magmatism. In magmatism, magma is very hot and is constantly moved by the internal heat that reaches the mantle of Earth through convective flow. Magma forms when rock reaches temperature between 800 degrees Celsius and 1200 degrees Celsius. Magmatism happens when magma is generated and develops into igneous and mud rocks. So in addition to this, magma originates in the lower part of the Earth's crust and in the upper portion of the mantle. Most of the mantle and crust are solid, so the presence of magma is crucial to understanding the geology and the structure of the Earth. All magma forms through melting of pre-existing rocks. Convection currents in the magma, so it drives the tectonic plates, the convection currents. as we can see in our image. Large convection currents, as you see in our image, in the asthenosphere located, transfers heat to the surface, where plumes of less dense magma break apart the plates at the spreading centers, creating divergent plates and also convergent plate boundaries. The process can take place either under the surface or on the surface of Earth to become part of the crust. The additional mass and volume to the surface of Earth forms mountains and volcanoes. So as you can see in our image, the magnetism starts in a partial melting region of magma located in the asthenosphere. Then the magma rises because of pressure and heat. After that, it goes to the crust, and the discontinuities that we have already discussed, no? The Muhov-Rovishik discontinuities. Then the process, the magma differentiate in the magma reservoir, intrusion, stagnation, and crystallization. The magma reservoir is the chamber wherein you can find a large portion of magma. The intrusion continues until it extrudes to the event of the volcano. Volcanic eruption, extrusion of lava happens there. Then the volcanic gases mix with the atmosphere. Those volcanic gases is called a tephra. That is the process of magmatism. So in addition to this, magma forms from partial melting of mantle rocks. As we can see in our image, the rocks move upward or have water added to them. They started to melt a little bit. Eventually, the pressure from these bubbles is stronger than the surrounding solid rock, and these surrounding rock fractures, allowing the magma to get to the surface of the Earth. Next, we have volcanism. Volcanism is a process that usually happens after the magma is formed. The magma tries to escape from the source through openings such as volcanoes or existing cracks on the ground. Magma comes out with extreme heat and pressure and may cause destructive explosion. That is in the process of volcanism. Magma that reaches the surface of the Earth is called lava. So in addition to this, magma can also extrude into Earth's atmosphere as part of violent volcanic explosion. Through the process of volcanism, this magma solidifies in the air to form volcanic rock. In the atmosphere, tephra is more often called a volcanic ash. So if it is solidifies, it is also called tephra. But in a form of the gas, it is also often called volcanic ash or tephra when it is solidifies. The magma that goes out to the surface of Earth is called a lava, as I have mentioned a while ago, and when the lava solidifies, it forms a volcano. Next, we have metamorphism. Metamorphism is the process of charging the materials that make up the rock. The chemical components and geologic characteristics of rock change due to heat, fluids, and pressure. That is the agent in metamorphism. That is increasing or decreasing. So we can say that metamorphism is variable in its characteristic because it is increasing and decreasing. The minerals in the rocks may change even if it does not melt. So in addition to this, metamorphism occurs because some minerals are stable only under certain condition of pressure and temperature, as well as only in a specific place for as much as possible. When pressure and temperature change, chemical reaction occurs to cause the minerals in the rock to change to an assemblage that is stable at new pressure and temperature condition. As we can see in our image, there is a changing in state of a rock from shale to slate to schist to gneiss and to migmatite. So we have types of metamorphism to be discussed and their formations. The first one, we have the contact metamorphism. Contact metamorphism happens when a body of magma intrudes into the upper part of the crust. Heat is important in contact metamorphism, but pressure is not a key factor. So contact metamorphism produces non-foliated metamorphic rocks, such as hornfels, marble, and a quartzite. So a non-foliated metamorphic rocks are such as those rocks that don't have layer and don't have the appearance of a strand. They are considered to be non-foliated. Any type of magma body can lead to contact metamorphism, from a thin dike to a large stock. Okay, so a dike in geological perspective is a sheet of a rock that is formed in a fracture of a pre-existing rock body. A stock is an igneous rock or an igneous intrusion that has a surface exposure or of less than 100 square kilometers. It is differing from batholiths only in being smaller. Batholiths is larger than this stock. Stock has a discordant relationship with the rocks that it intrudes, for example. The type and intensity of the metamorphism and width of metamorphic areole that develops around the magma body will depend on a number of factors, including the type of country rock, the temperature of the intruding body, the size of the body, and the volatile compounds within the body. So, in addition to this, areole is a ring around an igneous intrusion, as you can see in our image. So pinapalibutan niya yung magma chamber. Deep magma bodies cool very slowly because of heat and pressure and turn into a coarse-grained plutonic rocks like granite and gabbro. During this time, they make a zone or areole of contact metamorphism in the process. It is now resembles in the country rock. A large intrusion will contain more thermal energy and will cool much more slowly than a small one, and therefore will provide a longer time and more heat for metamorphism. This will allow the heat to extend farther into the country rock, creating a larger areole. So in addition to this, country rock is the rock native to an area, or a rock that is common in an area where it is located. In contrast to any intrusion of viscous geologic material, commonly magma or perhaps a salt, or any unconsolidated sediments. So as we can see in our image, country rock usually located above the magma chamber. That happens that a large intrusion will contain more thermal energy at the bottom. Contact metamorphic aureole are typically quite small, from just a few centimeters around small dikes and seals to as much as 100 meters around a large stock. Contact metamorphism can take place over a wide range of temperature, from around 300 degrees Celsius to over 800 degrees Celsius. Different minerals will form depending on the exact temperature and the nature of the country rock. So a seal is a tabular sheet intrusion that has intruded between older layers of sedimentary rocks, beds of volcanic lava, or tuff or along the sedimentary affiliation in metamorphic rock. A seal is a concordant intrusive sheet, meaning that a seal does not cut across pre-existing rocks. So nakikita natin, hindi siya doon mismo sa pagitan ng dalawang magkaibang rocks. For example, metamorphic and sedimentary. So we have also another types of metamorphism, the regional metamorphism. On the contrary, regional metamorphism is the other type where a change in the rocks happens in a larger or more extensive area. So, mangyayari lang po yung regional metamorphism sa movements ng dalawang plane. Ibig sabihin, dapat merong existing rock na mangyayari para magkaroon ng regional metamorphism. It should be noted that the rock changing due to weathering and sedimentations that are not considered to have undergone metamorphism. So, regional metamorphism occurs when rocks are buried deep in the crust. This is commonly associated with convergent plate boundaries and formation of mountain ranges. So, nabubuo lang po yung convergent plate boundaries and mountain ranges with the movement of two plates colliding with one another. Commonly, it is in a compression motion, or is considering to be a compression stress. Because of boreal to 10 km to 20 km this is required, the areas affected tend to be large. Most regional metamorphism takes place within a continental crust. So, makita natin siya usually sa mga continental crust and also sa mountain ridges, even yung mga mountain ridges na nakalubog sa tubig. Refers to a large-scale metamorphism, that is regional metamorphism, such as what happens to continental crust along convergent tectonic margins where plates collide. The collision result in the formation of long mountain range like those along with the western coast of North America. So a western coast of North America is an example of regional metamorphism happens between two plates colliding to form a mountain range. So a convergent plate boundaries, it has a plate collision that occurs. These areas can produce also an earthquake, volcanic activity, and crustal deformation. The Himalaya range is an example of where regional metamorphism is happening because two continents are colliding. Sedimentary rocks have been thrust up to great heights, nearly 9 km above sea level. So yung Indian plate nag-collide sa Himalayan or Himalayas range. For example, so ano yung nagbuhat ng Himalaya range pataas? So yung Indian plate, as we can see in our image. So that is a bright example of metamorphism in a large scale. So because it is considering the normal geothermal gradient, the rate of increase in temperature with a dip, as we can see, is around 30 degrees Celsius per kilometer in the crust. Rock bored to 9 km below sea level in this situation. This could be close to 18 km below the surface of the ground, and it is reasonable to expect temperature up to 500 degrees Celsius. So tumataas yung temperature with the subducted plate of Indian plate as it moves downward in our image. So in this image, we notice that the sequence of rocks by the process of regional metamorphism. From the beginning, we have the slate, higher up where the pressure and temperatures are lower, and ending in migmatite, as you can see here in our image at the bottom, where temperatures are so high at some of the minerals start to melt. So yung migmatite, mas malapit siya sa magma chamber. So siya yung na-encounter niya yung extreme heat and pressure kasi nasa ilalim siya. Mas malapit siya doon sa subducted lithosphere wherein nakalocate din doon yung magma chamber natin. So these rocks are all foliated because of the strong compressing force of the converging plates. Lahat ng ito is all foliated rocks. So in addition to this, slate was formed under low-grade metamorphic conditions. Bakit low-grade? Kasi nasa pinakataas siya. So yung heat and pressure na nakukuha niya is very low. That's why it has a low-grade metamorphic condition. Under relative low temperature and pressure, the original material was a fine clay, sometimes with sand or volcanic dust, usually in the form of a sedimentary rocks. Migmatites, on the other hand, form under extreme temperature and pressure conditions during regional metamorphism, when partial melting occurs near the subducted lithosphere. So these are all foliated rocks, such as this slate. They have a layered or banded appearance that is produced by exposure to heat and directed pressure, opposite to the definition or description of non-foliated rocks. We have also the boreal metamorphism. So when we say boreal metamorphism occurs when sediments are bored deeply enough that the heat and pressure cause minerals to begin to recrystallize and new minerals to grow, but does not leave the rock with a foliated appearance. As metamorphic process goes on, boreal metamorphism takes place at relatively low temperature, up to negative 300 degrees Celsius. To the unaided eye, metamorphic changes may not be apparent at all. So we have an example of boreal metamorphism in our image. It contrasts the rock known to be commercially as black marinese gold granite in our figure, but which is in the fact a metaconglomerate with the form through boreal metamorphism. The metaconglomerate is a type of metamorphic rocks formed through the process of metamorphism. It does not display any of the foliation that has developed in the metaconglomerate in our figure. We have also the hydrothermal metamorphism. So hydrothermal metamorphism occurs when hot chemically active mineral-laden waters interact with surrounding pre-existing rock called the country rock. Most of the hydrothermal metamorphism takes place at low pressure and relatively low temperature as the phase diagram shows. So nangyayari lang yung hydrothermal usually happens in our subsurface or the submerged surface of the oceanic crust. That is why it has a low pressure and relatively low temperature as well. Kasi nakalubog siya sa tubig. At an oceanic spreading ridge, for example, in our image, recently formed oceanic crust of gabbro and basalt is slowly moving away from the plate boundary. So hydrothermal metamorphism happens when rocks that are altered at high temperatures and moderate pressure by hydrothermal fluids. Sabihin, it happens that it will result to low pressure and relatively low temperature. This kind of condition is common in basaltic rocks that is generally lack hydrous minerals. An oceanic spreading ridge is a fracture zone along the ocean bottom. Yan yung nakikita natin dito sa image where molten mantle material comes to the surface, thus creating a new crust. So, magkakaroon din ng mga mountain ridges sa ilalim ng dagat. Hindi lang po yung nangyayari dun sa continental crust, kundi pwede rin magkaroon ng mountain ridges sa dagat. This structure can be seen beneath the ocean as a line of ridges that form as molten rock reaches the ocean bottom and solidifies to form a range of mountains. The low-grade metamorphism that we have already discussed, occurring at these relatively low pressure and temperatures, can turn mafic igneous rocks in ocean crust into greenstone. So, nagkukulay ng berde yung bato, no? Form into a greenstone. A non-foliated metamorphic rock. So, wala siyang strand or bands appearance. We have also the subduction zone metamorphism. At subduction zone where ocean lithosphere is forced down into the hot mantle, there is a unique combination of relatively low temperatures and very high pressures. So yung subduction zone metamorphism happens when two plates colliding. Yung isang plate, it carries the other plate, and the opposite plate also in compression. Opposite yung direction ng arrow natin dito. So dapat in compression ng stress na ina-apply ng dalawang plate. The high pressures are to be expected given the force of collision between the tectonic plates and the increasing lithostatic pressure as the subducting slab is forced deeper into the mantle. So yung green image or green plate na yan, with low metamorphism, yan yung plate na nagsasubduct or moves under deep within the earth until it goes to the portion of the mantle. The lower temperature exists because even though the mantle is very hot, ocean lithosphere is relatively cool kasi nakalubog siya sa tubig and a poor conductor of heat. We have also the shock metamorphism. When extraterrestrial objects hit Earth, yung extraterrestrial objects, yan yung mga heavenly bodies or space object na makikita natin sa outer space. Just like comets, asteroids, meteorites, those are example of extraterrestrial objects. The result is a shock wave pag tumama siya dito sa lupa, where the object hits, pressure and temperature become very high in a fraction of a second. Pag bagong tama pa lang, we have those shock waves result in a very high temperature. A gentle impact and heat with a 40 gigapascal, yan yung pressure na nakuha niya, and raise temperature up to 500 degrees Celsius. Pressures in the lower mantle starts at 24 gigapascal and climb to 136 gigapascal at the core mantle boundary. So yung pinakagitna, yan yung pinakagitna na tinamaan ng extraterrestrial objects. Yan yung nakaka-absorb ng pinakamataas na pressure and heat. The sudden change associated with shock metamorphism makes it very different from other types of metamorphism that can develop over hundreds of millions of years, starting and stopping as tectonic condition changes. Next, we have the dynamic metamorphism. Dynamic metamorphism is the result of very high shear stress, such as occurs along fault zones. The dynamic metamorphism occurs at relatively low temperatures compared to other types of metamorphism and consists predominantly of the physical changes that happens to a rock experiencing shear stress. So, nangyayari lang to pag nagkaroon ng sideway movement between two plates or in a result of an earthquake. It affects a narrow region near the fault and rocks nearby may appear unaffected. So, dynamic metamorphism defines itself. When we say dynamic, it is a changing in the movement of two plates in sideway motion or shearing motion. Dynamic metamorphism occurs as a result of mechanical deformation, yung fault lines na tinatawag natin, like when two bodies of rock slide past one another. Yung tawag sa shearing stress na yon ay yung dalawang bodies of rock which will slide past one another. Nagkakaroon sila ng shearing stress. At nangyayari yon sa mga fault lines or fault zone na tinatawag. Heat is generated by the friction of sliding along such as shear zone. So kung walang shearing, wala ring friction na magaganap. And the rocks tend to be mechanically deformed, being crushed and pulverized due to the shearing. So due to the shearing, there is a metamorphism happen. No? There is a metamorphism that will happen. Friction produces heat and pressure. Dynamic metamorphism is not very common and is restricted to a narrow zone along with the shearing occur. So bright example for this is the fault lines that nakita natin sa San Andreas fault, as we can see in our image. So yan yung nakakaranas usually ng dynamic metamorphism. Next, we have a new topic, types of stress influencing rocks behavior. So when we say stress, so when people have too much stress, just like us, we may break. What happens if a rock gets too much stress also? Okay? So with all the movement occurring on Earth's surface, slabs of crust smashing into each other. Sideways movements along faults, magma rising through solid rock. It's no wonder that rocks experiencing too much stresses. So rocks respond differently to different types of stress and under different conditions. Basically, we define stress as the force applied to an object. So in a geologic term, stress is the force per unit area that is placed on a rock, for example. So we have the 4 types of stresses. So the geological process that happens on Earth make land masses called plates push or pull each other. In so doing, stress happens that there are 4 types of stress. We'll discuss one by one. The first one, we have the compression stress. Rocks push or squeeze against one another where the stress produced is directed toward the center. So yung pinaka-maximum deflection nito nangyayari sa pinaka-gitna ng plate because of decompression. So opposite yung direction ng arrow natin para magkaroon ng compression. So forces collides one another. Okay, so in addition to this, compression squeezes rocks together, causing rocks to fold or fracture or break. So compression stresses is the most common stresses at convergent plate boundaries, wherein 2 plates collides. Next, we have tensional stress. In tensional stress, rocks are pulled apart. Rocks may separate in opposite direction. So opposite siya ng compression. Dito yung arrows natin away from one another. So ayan, lumalayo yung forces. So it also breaks the plate. It is speculated that this type of stress is what separated all the continents during the breakaway of the super continent known as Pangaea. So Pangaea is a super continent or a giant continent na naghiwa-hiwalay because of this tensional stress. So rocks that are pulled apart are under tension. Rocks under tension lengthen or break apart. So, nagkahiwalay sila. Tension is the major type of stress na nangyayari sa mga divergent plate boundaries. So kanina sinabi ko yung compression nangyayari sa convergent. Pero dito naman sa tensional stress, nangyayari siya sa mga divergent plate boundaries. Next, we have shear stress. Some of the portion of a plate at the edges may break away in different direction, eventually making the plate smaller in size. So, magkikiskisan na dalawang plate. Magkakaroon siya ng movement or tremors or vibration sa ground natin that will result to an earthquake in specific magnitude, for example. Depending on the condition of the environment, shear stress usually happens in different rates at the boundaries of the plate. The friction caused by this stress can cause earthquakes. Next, we have the confining stress. In confining stress, the crust becomes compact, thus making it look smaller. This is different from shearing as none of its edges break away. However, if breaking away should happen, the movement would come from the inside. When this happens, the shape of the crust can be retained through not its weight. In short, nothing may seem to have changes in the appearance because of changes have occurred inside. So, hindi natin mapapansin kung merong changes kasi nasa loob siya mismo. Yung changes, yung stress na nangyari, confined siya or nasa loob mismo ng Earth or Earth surface. In confined stress can cause sinkholes where the inside portion of the ground have already disintegrated without manifestation on the surface. So in addition to this, a deeply buried rock is pushed down by weight of all materials above it. Ibig sabihin yung forces na na-apply in confined stress are equally or evenly, no? Kumbaga distributed equally sa portion ng soil or ng rocks. So how a sinkhole form in case of confining stress? So the first is slightly acidic rainwater seeps into the sediment like limestone. Acidic rainwater dissolves away rock to expand fissures. Next, eventually, this erosion creates air-filled or water-filled pockets. When those pockets get big enough, they are categorized as caves or voids. Then, when the ceiling of a void weakens to the point that it collapses, that weakens, it's known as a sinkhole.